Hi scholars, I hope you're all doing great today. Today I'm wearing my college gear, represent University of Florida. That's where I got my undergrad degree in physics. Anyway, just wanted to share that with you guys. I am really stoked and excited about today. We are going to be starting a new unit. We're going into our final unit actually on electricity. So let us begin. The two tabs that you should have open are Google Classroom and then the classwork document that has been uploaded onto your Google Classroom. So as I mentioned, we are starting a new unit on electricity. Today's lesson is called The Introduction to Electrostatics. This title, Electrostatics, will make a little bit more sense in a minute. The materials that you need for today are your classwork document, as I mentioned, your notebook, so you can take notes on key points, and also pen and paper, pen or a pencil. So before we start, I just wanted to do a quick refresher. So in middle school, you learned about atoms and their components. You learned about electrons, protons, and neutrons. You also learned that electrons have a negative charge, protons have a positive charge, and neutrons are neutral in charge. And all these are called subatomic particles because they're subparticles within the atom. And charge, just like, charge is a property of matter, just like mass is also a property of matter. And you probably discussed that at the beginning of the school year when we talked about forces. So the aim for this whole unit is to understand the properties of electric charge and how electricity flows within the unit. So the first part of this unit is going to be focused more on electrostatics, meaning how charges transfer from one object to another. We're also going to be looking at the mathematical relationship that governs these interactions. We'll get into more detail about that later on within this unit, and also going to be seeing how all of this applies to real-life situations. In the second part of the unit, we're going to be learning more about how electricity flows. So how it moves within a circuit, what affects electricity as it's flowing, and what are the different components of an electrical circuit. So we'll have a little bit of a basic understanding about how is it that our lights turn on in our house, what happens in our cell phones, how our cell phones charge, our computers charge, and so on. For today, we are going to be looking at this driving question of how do charged objects interact with each other. In order to do that, first we're going to watch this quick video on what is electrostatics, or what is static electricity. It's the same word. Okay, so in your classwork document, there is a section for you to take notes on this video. Just write down any definitions of any keywords that come up that you might not know of, or any questions I might have, or any key or important points. So write that all into your classwork document. I am going to turn this on.
It can strike without warning, at any moment. You may be walking across a soft carpet and reaching for the doorknob when suddenly, zap! To understand static electricity, we first need to know a bit about the nature of matter. All matter is made up of atoms that consist of three types of smaller particles: negatively charged electrons, positively charged protons, and neutral neutrons. Normally, the electrons and protons in an atom balance out, which is why most matter you come across is electrically neutral. But electrons are tiny and almost insignificant in mass, and rubbing or friction can give loosely bound electrons enough energy to leave their atoms and attach to others, migrating between different surfaces. When this happens, the first object is left with more protons than electrons and becomes positively charged, while the one with more electrons accumulates a negative charge. This situation is called a charge imbalance, or net charge separation. But nature tends towards balance. So, when one of these newly charged bodies comes into contact with another material, the mobile electrons will take the first chance they get to go where they're most needed, either jumping off the negatively charged object or jumping onto the positively charged one, in an attempt to restore the neutral charge equilibrium. And this quick movement of electrons, called static discharge, is what we recognize as that sudden spark. This process doesn't happen with just any objects. Otherwise, you'd be getting zapped all the time. Conductors like metals and salt water tend to have loosely bound outer electrons, which can easily flow between molecules. On the other hand, insulators like plastics, rubber, and glass have tightly bound electrons that won't readily jump to other atoms. Static buildup is most likely to occur when one of the materials involved is an insulator. When you walk across a rug, electrons from your body will rub off onto it, while the rug's insulating wool will resist losing its own electrons. Although your body and the rug together are still electrically neutral, there is now a charge polarization between the two. And when you reach to touch the doorknob, zap! The metal doorknob's loosely bound electrons hop to your hand to replace the electrons your body has lost. When it happens in your bedroom, it's a minor nuisance. But in the great outdoors, static electricity can be a terrifying, destructive force of nature. In certain conditions, charge separation will occur in clouds. We don't know exactly how this happens. It may have to do with the circulation of water droplets and ice particles within them. Regardless, the charge imbalance is neutralized by being released towards another body, such as a building, the earth, or another cloud in a giant spark that we know as lightning. And just as your fingers can be zapped over and over in the same spot, you better believe that lightning can strike the same place more than once.
I hope you guys found that video interesting and you get a little bit of an idea of what static electricity is. I know there's a lot of vocabulary words that were used there that might have been, you might be unfamiliar with. But as we go along with this unit, all of these concepts will make more sense. All right, so let's move on. So now I want you to start with this quick do now question. Based on what we just saw, have you ever experienced a shock when you're touching a doorknob, shake someone's hand, or heard a crackling noise when you take off a wool sweater in the winter? Why do you think this happens? And so it was kind of explained in the video, but you can try using your own words to explain what just happens. Take the next minute or so in your in the classwork document to respond to this do now. When you are ready, you can hit pause, and when you're ready to come back, press play to join us. Okay, welcome back. So you could have said things like, there's a transfer of electrons from the doorknob to your hand, or the noise could have come from just like we say the word static a lot, you know, like so when you take off your wool sweater, it's like, oh, it was staticky. So we're going to be defining what these things mean more throughout this unit, and particularly this lesson. Alrighty. So keep in mind your answers to the do now, and they'll become clear throughout the end of this class. This guy looks a little crazy. I'm going to show you another video. We're going to be watching around 3.5 minutes or so of this demonstration. It's going to, this professor is going to explain to us, and with some demonstrations, what exactly is happening when there's transfers of charges. Okay, so let's start.
opposite. Rubbing here. Hello, I'm Bruce Yang, and today I have my students doing an activity on static electricity and the behavior of materials at opposite ends of the triboelectric series.
We find that chemicals at the top of the list give up electrons and become positively charged, while chemicals at the bottom of the list gain electrons and become negatively charged.
Just as a quick disclaimer, you don't have to know what all these chemicals are. It's just listed here for you to become aware of it. And then also this word triboelectric effect, it's a new word that you probably haven't heard of before, but it's not something that you need to memorize.
So we're going to take a look at pairing up chemicals from opposite ends of this table.
So let's get started.
My students would start off with two pieces of vinyl. One piece they would attach a string to and hang it up from the bar or a table. The second material is acetate. Once again, they would have two pieces. They would hang one of the pieces up from a bar or table. Our first test is simply to bring the materials near each other without actually rubbing them. And when we do that, we'll find there's really no reaction. Now let's try rubbing that vinyl strip with wool. Now when we do this, I do want to rub both the strips. I'll start with the one that's hanging down. Get both ends of it. There we go. And now I'll rub the second strip with the wool. Bring it near. And it pushes it away. Now why is it doing this?
Now the process we're looking at is sometimes referred to as friction charging. The word triboelectric, well, tribo comes from the Greek word meaning to rub. And electric, of course, refers to the positive and negative charges. But it's not really friction that's creating the charge. It's actually a chemical reaction due to adhesion. Now these vinyl strips are evenly charged, but when I rub them with wool, what I'm actually doing is depositing electrons on them, so overall they become negatively charged. And when negative charges get near other negative charges, they repel, they push each other away.
Try doing it the other way. See if it's just What? Oh, it is working. No, it isn't. It's working. Look. Yeah, it works.
Now let's try it again. In this case, I'm going to use the acetate strips and rub them with Orlon. And as I get it near it, once again, we see that it's pushing it away also. Now in this case, when I rub the acetate strips with Orlon, I'm actually removing electrons, and that's going to make them positively charged. Once again, when I have positive charge near a positive charge, they're also going to repel each other or push each other away. So our next test will be what will happen if we bring the negatively charged strip near that positively charged. I'll rub the vinyl again with the wool and make it negatively charged. We see it's repelling that strip. And when I get it near the acetate, we see that it attracts it. Now let's try it with the two acetate strips. Once again, they push away, but if I bring it near that vinyl strip, once again, there's our attraction.
I remove electrons and the acetate becomes positively charged. I rub the vinyl and add electrons so it becomes negatively charged, and the positive and negative charges attract.
Now, one more note. It's important to remember that both materials get charged. When the acetate gets positively charged, this Orlon, as we can see, is now negatively charged.
Now that we've established our charges, we can try other materials on that table and see if they behave the same way.
We're going to stop our video here. So make sure that you go back and take notes on this. I forgot to mention at the beginning of the video that you should have been taking notes on here. So if you didn't do so, please go back and write down anything that you found interesting here. In particular, what are the interactions between, what did we observe between the different types of materials that were placed in proximity to each other? Okay, before we move on to our next section, let's do a quick check for understanding. In your classwork document, I want you to, classwork document, I want you to respond to this question. How does friction generate static electricity? Right, and whichever option you choose, make sure to explain your reasoning. Take the next minute or so to answer this question, and whenever you're ready, you can pause, and whenever you're ready, hit play so we can continue. All right, welcome back. So the second to last thing we're going to do today is do a reading. So the reading is in your classwork document. I want to make sure that you annotate by using the highlighting feature and make comments on the right margin. Make sure to annotate for new definitions and key concepts. This reading here is going to help clarify all the videos that we've been seeing, that we've watched so far. All right, so you can press pause when you're ready to start the reading, and press play when you're done so we can continue on. All right, scholars, welcome back. The key points that you should have arrived at during the reading are that static electricity arises from the transfer of electrons from one object to the other. So protons never move. If you remember from the structure of an atom, the protons and the neutrons are like stuck in the middle, and then the electrons are kind of like on the outer edges. So the electrons are moving from one object to the other, but the protons will never move. When objects, and then the other key point is that when objects are rubbed, they might attract or repel other objects. Again, this depends on the material. If I just rub my pencil with my finger, nothing's gonna happen. There have to be materials where the electrons or the outer electrons will easily transfer from one object to the next, and that depends on the type of material that it's made out of. So like charged objects repel, and opposite charged objects will attract. And that relates to the video that we saw with the pieces of plastic that were hanging from a string. How sometimes, depending on what material those plastics are rubbed with, they either were positively charged and repelled, or they were oppositely charged and attracted. Okay, so as for your exit ticket, I want you to watch this GIF that's here. So you can see here what's happening to the girl. She goes down the slide. I'm just gonna watch that one a few more times. And using the new vocabulary that you've learned today, explain why the little girl's hair rises as she's sliding down. Look. Whoop. The little girl looks surprised. So you've probably experienced that yourself when you were a kid going down slides. So why do you think this happens? Okay, make sure to add that into your classwork document. And just as a reminder, don't forget to submit your classwork document to Google Classroom by the end of the day. And I hope you have a wonderful day. Take care, y'all.